In this activity, we're going to look at things a little bit differently. And instead of the projectile taking off from ground, it's going to take off from a platform. Reads, a rocket is placed on a platform 15 feet above ground level and is shot straight up into the air. The rocket hits a max height that is approximately 26.5 feet in the air at time equals 1.5 seconds. It lands on the ground at time equals 3.85 seconds. In the previous lesson, we talked about setting up a point with x and y, and we discussed how x would be time, which is the independent variable, and y would be height, the dependent variable. Let's set up a few points so that we can make a sketch of what's happening. Out of the problem, it says a rocket is placed on a platform at 15 feet above ground level. We know that 15 feet above ground level is going to be a height, and the time at which the rocket takes off should be 0. So let's set up that first point. 0, 15. A second point, the rocket hits a max height that is approximately 26.5 feet in the air, and that occurs when the time is 1.5 seconds. So that point is going to be time first, being 1.5, and height second, 26.5. We know it lands on the ground at time equals 3.85 seconds. If it lands on the ground, the height should be 0. So that point would be 3.85 and 0. Let's come over to the graph and make a sketch of it real quick. So start with an x and y axis. On the x-axis, we'll put our units, which is time, in seconds. And on the y-axis, we'll put height. And the units we're talking about here are feet. So I'm going to scale this out, and I'm going to go ahead and skip every 4 just for ease right now. And, well, let's do this every 2 instead and go 1, 2, 3, 4 along the x-axis. And along the y-axis, we're going up to 26.5, so we can go by 5s. I'll skip every other one too. 5, 10, 15, 20, 25, 30. Okay. I'm going to go ahead and change colors just so it's easier to see for you. Let's sketch the first point, which is 0, 15. 0, 15 is 0 on the x, 15 on the y. So I'm going to go to 0 and up 15, make a point. I'm going to go 1.5, 26.5 is the second point. Well, I know where 1.5 is, it's halfway between 1 and 2, so that's an easy one to get. But we're going to have to estimate 26.5 on the graph, as it doesn't necessarily show all those values. And because it doesn't show that, I'm going to go ahead and write that. 1.5, 26.5, right next to that point so we know exactly what's happening. And the last point, which is 3.85 and 0, which is going to be, I'll place it right before 4. Let's go ahead and make that sketch. We know from the previous lesson that this is parabolic and should curve like a U. Now in this case we have a little problem, and mainly if you notice the graph right now, it's not complete. We should have an idea that one side of the parabola should be exactly the same as the other side of the parabola, and we called that the axis of symmetry. So I'm going to take a ruler, I'm going to draw in that axis of symmetry. Okay. So we know this should be the same as this over here. You'll notice I asked for 4 points. And we have 1, 2, 3, so we're missing one. The one that we're missing is the one that continues down and hits the x-axis over here in the negatives. This is an easy point to find. This x value right here is 3.85, and this x value with the axis of symmetry is 1.5. We'll start by finding the distance between those 2 points. In order to do that, I'm going to take 3.85 and I'm going to subtract off 1.5. Okay? What you should have here, left over, 3.85 minus 1.5, it's going to be 2.35. We know that from here to here is 2.35, and it should also be 2.35 on the bottom piece. This is a distance. So we're going to start, to find this point down here, we're going to take 1.5 and subtract off 2.35. When we subtract these, you should see negative 0.85. So this parabola, as it continues down, hits the x-axis at negative 0.85 and a height of 0. I know it doesn't make sense to have negative time, but when continuing the parabola and making equations later on, you'll need that point. D, estimate when the rocket is 15 feet in the air. This is very similar to what we did in the previous lesson. So we're going to go to 15 feet in the air, and if you notice, that's going to be on the y-axis. And at 15 feet, I'm going to draw a line straight across. And just make some approximations, not any calculations. So we know it's 15 feet in the air at time equals to 0. We also know at that intersection right there that it's right after 3 sometime, so maybe about 3.25. We don't have to be exact right now. Estimate how high the rocket is at 2 seconds. In this case, we're starting with 2 seconds, which is the time. So we're going to start by looking at the x-axis with time, 2 seconds, and we're going to move up. And it's got to be about at that intersection. Now we know the highest is 26.5, so it's below that. So I'm going to estimate right at about 25.